Okay, so today we're going to continue reviewing. Today is section 5, and we're going to learn how to simplify rational expressions. When you see simplifying rational expressions, another way that you might see the instructions, they'll say put it in lowest terms. So a rational, or the definition of rational, is any number that can be written in fraction form, like a divided by b. Always remember, though, that the denominator cannot equal 0. And that's going to become important to us later on when we solve rational expressions or equations. We're going to have to state what numbers would make the denominator 0. And we would exclude those from our answers. So when you are simplifying a fraction, when you learned it back in elementary school, they probably told you to reduce your fraction by factoring out or dividing by the greatest common factor. And that's what we're going to do here. Now, I know a lot of times when you guys are simplifying fractions, you might have something that looks like, say it's 10 over, let's say 12 over 16. And this is just a simple form of a fraction. Our fractions are going to be more complex. They're going to have variables. A lot of times I know when students look at a fraction and they see two even numbers, they think, I'm just going to divide it by 2. So, but the proper way to do it would be to divide by the GCF. And the GCF here would be 4. So you could divide them both by 2 and get 6 over 8, but then you would have to continue simplifying. Whereas if you divided initially by the greatest common factor to reduce it, which was 4, it would go right to its simplest form. So this is what we're going to be doing. We're going to be pulling out GCFs of our polynomials so we can simplify our rational expressions. So we're going to get right into some examples. Now, in Algebra 1, you should have learned about grouping symbols. And the most common type of grouping symbol is either a parenthesis or a bracket. Now, what you also have to consider is another type of grouping symbol is a fraction bar. So when you have something written in fraction form, so for example, if I have x plus 5 on the top and x plus 5 on the bottom, these are considered grouped together even if they do not have parentheses around them. So when we go to simplify our rational expressions, for example, this is going to simplify, and anything divided by itself is 1. So this rational expression would simplify to a 1. If I have something that looks like x plus 1 over x plus 5, remember these are grouped together, and I cannot just cross off the x's and be left with 1/5. This is staying all together, and the only way I could simplify it is if it looked exactly the same. So remember that a fraction bar is also a grouping symbol. All right, so in these examples, I've actually written the question and I've put the binomials in parentheses. So it makes it a lot easier to simplify. So we're going to express each one of these in simplest term. And what I'm doing is I'm looking for something that will match the top and the bottom, or divide it. So here I could see that I have an x plus 1 in the top and then an x plus 1 in the bottom. So if I rewrite it here, just to show how it's changing from what it started with, I'm going to do x plus 1 divided by x plus 1, or simplify these both to 1s, and then I'm left with my final answer as x plus 2. And that would be the simplest form of that rational expression. So again, I've rewritten it, and now I've canceled out my two like terms here, and now I can simplify, and I'm left with x. All right, let's try the next one. Can I simplify anything here? Now, notice I did not put parentheses around the numerator, but you need to remember that this is a grouping symbol. It's a fraction bar. Can I reduce anything here? What can I simplify? Anything? Or is this already in simplest form? It's already in simplest form. Remember, I told you at the beginning, I cannot, so let me rewrite this. This is grouped together. So in order to cancel this away, it's gotta be the whole thing that's gonna cancel out. I can't do an X and an X and be left with 1. So this question is already in simplest form. It's already simplified. You can't just cross off the X's, it's attached. Number 4. Okay, here comes our factoring. Anybody recognize the top? What is that called? Okay. So we're going to factor it first. It's the difference of two squares. The denominator is grouped together. That's an a plus 4. And now I can begin to try to simplify. Can I simplify anything in that rational expression? Okay, I can cross off the a plus 4s. Because a plus 4 divided by a plus 4 is 1. They both become 1s. And then I'm left with just a minus 4. And that's your simplified rational expression. Okay, number 5. What can I do here? I'm looking to factor some stuff. I got to factor this one, both the numerator and the denominator. What can I do to my numerator to factor that? Perfect. What is it?
6.
Excellent. So I'm going to pull out a GCF, and that's going to be 6. After I divide, I'm left with x plus 5. What about my denominator? What is that? Perfect squares. So I'm going to square root them, and it becomes x plus 5, x minus 5. Again, it doesn't matter the order that you write the plus 5, minus 5. And then now, can I simplify anything? Okay, I can cross off the x plus 5s. That will simplify. And now I'm left with 6 over x minus 5. I don't need to write parentheses around it. If you do, it's fine, but you can leave it just like that. We're applying all of our R4 factoring techniques, and then we're going to look for things that will simplify so we can get our rational expression in lowest terms. Let's try number 6. This was last night's homework, this top part. What will the numerator factor into?
X plus 4 squared.
Perfect. That is a perfect square trinomial. So I can either write it as x plus 4 squared. Just so I have things to cancel out, I'm going to write it as the two binomials. Then the denominator is what? The difference of two squares. So 4 minus x and 4 plus x. Now, remember, addition, you can apply the commutative property. Remember, the order that you add two numbers doesn't matter. So what can I simplify here?
X plus 4 and 4 plus x.
Perfect. Okay, and then you're left with x plus 4 over 4 minus x, and you're finished. All right, what can we do to the numerator? GCF. What's it going to be?
4x.
Perfect. So 4x is going to be the GCF. I'm going to divide, and I'm left with x minus 2. Okay, now I have 4x to the third on the bottom. Can I simplify anything here? Right? I can simplify the 4s and one of the x's, correct? Good. All right. Now, you could think of it like this. You could expand it. So like you could rewrite the numerator. And if you wanted, you could show that this is 4 times x if that helps you. And then you can see that there's a 4 and an x here and a 4 and an x here. And then when you go to put it back in your answer, put those two x's back together. Another way you could do it is break the 4x cubed into 4x times x squared, because remember when you multiply, you add exponents. So you could also break it apart that way. And then show the 4x minus 2, and then simplify it that way. So they both end up with x minus 2 over x squared. All right, so for this one, what do I need to do? Okay, the difference of two squares is the numerator. So I'm going to break it into 5 minus x and 5 plus x. Okay, my denominator though, that looks like last night's homework. What can I do, Ryan?
So you do what number multiplies 35, and that's do 12, and that's going to be x plus 5 and x plus 7.
Beautiful. Okay, so everybody understood what he did? What two numbers multiply to give 35, but add to give you 12? So we can see that 7 times 5 is 35, and then 7 plus 5 is 12. And again, the order does not matter. You could have put in the x plus 5 first, and then the x plus 5 second. Doesn't matter. Okay, what can we simplify here?
The 5 plus x.
Good, the 5 plus x and the x plus 5. And then our final simplified answer is going to be 5 minus x, x plus 7. What are we going to do? Okay. Who said GCF? All right. What is it going to be? 5. Okay. So divide both by 5. And then rewrite the x minus 2. And then now what can I simplify? The x minus 2's. And then this answer simplifies to plain old 5. All right, I'm going to divide this one by 6, and I get x plus 2, and then this one stays the same. So this is what I'm going to write in the denominator now, is the factored form of that trinomial. So x plus 2, and then 6x minus 5. And then now what can I simplify? Just the x plus 2's. So this final answer is going to be 3x over 6x minus 5. Again, remember, I can't simplify that 3x and that 6x because the denominator has the minus 5 attached to it. I would have to be able to simplify a 3x out of both terms. So that is the simplest form for that question. I've got a few little notes here, key points for you to remember. Remember, anything divided by itself is 1. So you're dividing or simplifying x plus 1 over x plus 1, it equals 1. And then here, x minus 1 over x minus 1 also simplifies to 1. But when the signs are different, this one has already simplified. I can't do anything to it. I can't cross off the x's, and I can't simplify it to a -1. However, this one does simplify to a -1. Because watch what I can do to this one. I could take the denominator, the 1 minus x, and I can factor out a GCF of -1, and then I can flip the signs around. And now what I have is x minus 1 on the top, then the factored bottom, and then notice the x minus 1's cancel, and now I'm left with 1 over -1, which simplifies to -1. So Be very careful when you see the signs are backwards like this. It will reduce to -1.